This is part 2 of the review for the statistics test. This is starting with question number 4, so this is the back page. It says the table below represents the normal high temperature in Charlotte for each given month. And you can see, again, this is the normal high temperature for each month of the year. Part A says what is the range for the data. So the first step is to plug in your data, which I went ahead and did over here in L1. To get the range, we go to Stat, Calc. Make sure it's L1 since that's where my data is. Hit calculate, and the range is the max minus the min. So the max is 89 minus the minimum of 51 gives me an answer of 48 for the range. So the range is the max minus the min. Then it asks for Q1, Q2, and Q3. That's also in that one variable statistics. Q1 is 58.5. Q2 is the same thing as the median, which is 72, and then Q3 is 83.5. The interquartile range we do by doing Q3 minus Q1. In this case, 83.5 minus 58.5, and that gives us 25. Finally, it asks for the standard deviation. The standard deviation is this right here. So we get 13.32. Okay, question number 5. Use this data, which I already have plugged in. Make sure you plug it in for yours. I plugged it in mine in L2 just so I could have them both in there at once. What is the interquartile range? So I'm going to go to Stat again, go to Calc, and then one variable statistics. I need to change this to L2, so I'll hit second 2, and that plugs in L2 for me. So now the interquartile range, remember, is Q3 minus Q1. So my Q3 is 66, my Q1 is 40, so subtracting those two gives you 23. Excuse me, 26. 26 is the interquartile range. The standard deviation, I just showed you where to find that in question 4. It's right here. So we get a standard deviation of 16.291. And then the variance, that should say variance, not variation, my fault. The variance is that number squared. So we take 16.291 and square it. I get 265.397. And finally, it asks us to draw a box and whisker plot for the data. Okay, we can do that in our calculator as well. Go to second stat plot, it's right above y equals. Go into plot 1, make sure it's turned on. Make sure that this part is highlighted. On mine it already is. And because I have my data in L2, I have to change my X list. If you put yours in L1, you can leave it just like it is. But I have to change mine because of where I put my data. Okay, once I get that done, I go to quit, and then zoom stat, which is zoom 9. And that shows me what my box and whisker plot should look like. To get the actual values to draw it, I go to trace, and then I see that my minimum is at 30. My Q1 is at 40. My minimum is at 56. My Q3 is 66. My maximum is 79, and it does not appear that there are any outliers, so I don't have to worry about those. Okay, so once again we had the minimum at 30, that's the bottom whisker. 40 was Q1, 56 was the median. Need to double check what those last ones were. Okay, the max was 79 and Q3 was 66. And that's what it would look like. Okay, number 6, identify the following as normally distributed, skewed left or right, or uniformly distributed. This first one, A, is uniformly distributed. It's symmetric. It looks like a bell, so that's uniform. Oh, no. So sorry. Whew. Not thinking. This first one is normally distributed. Anything that looks like a symmetrical bell is going to be normally distributed. This next one is skewed right. Okay? Skewed right. Because if you look at the top as the center, then there's more stuff to the right than there is to the left, so it's skewed right, which makes this one skewed left for the same reason. There's more stuff to the left of the peak than there is to the right. And then this one, this flat one, is the one that's uniformly. It's the same everywhere, so it is uniformly distributed. Final question. If you have a set of 750 values and they are normally distributed with a mean of 66 and a standard deviation of 5, sketch the normal curve that would represent this distribution. Alright, when you're sketching a normal curve, you put the mean in the center, and then you go up 1 standard deviation, up 2 standard deviations, up 3 standard deviations and quit, then down 1, down 2, down 3. And draw your bell curve. So that's what we should be going for there. You don't have to do the dotted line. I do that just to kind of help myself with the center, make sure I know what I'm doing. So B says, what percent of the data would fall in the interval 61 to 71? Well, 61 to 71 is 1 standard deviation above or below, and as I told you to memorize, 1 standard deviation above or below covers 68%. I will have that one blocked out so you can't see the 1, 2, and 3 on the test tomorrow. Those 3 you have to have memorized. C, what percent of the data would fall in the interval 63.5 to 68.5? Okay, so that would be right here, 63.5, and right here, 68.5. So if you look closely, you realize those are 2.5 above or below 66. Well, 2.5 is exactly half of the standard deviation. So that means we're going half a standard deviation above and below the mean. I'll have this chart for you on the board tomorrow. So we look and we say, okay, here's half of a standard deviation. So we have 38.3% in that range. D says find the interval about which the mean, that includes approximately 38% of the data. So we're kind of going backwards from what we did in part C. If I go to my table and look for it says 38%, ironically, doubt this will happen on your test, it was the same thing we already used. This was closest to 38%, so that's exactly half of a standard deviation. So the interval would be exactly what we had before, 63.5 to 68.5. Because half of the standard deviation is 5, so that's 2.5. And if you do 68 plus 2.5, you get 68.5. If you do 66 plus 2.5, you get 68.5. Or 66 minus that, you get 63.5. Okay? And then finally, how many values would fall on the interval 56 to 76? Alright, that is 2 standard deviations above and below. So some of you are probably thinking, oh, well, that's 95%. That's one of the ones we memorized. That's true, but it didn't ask what percentage of values fall in that range. It said how many values fall in that range. If you look back at the problem, it says there are a total of 750 values. And we know 95% of those fall in this range because that's 2 standard deviations. So you have to take 95% of 750. We can do 0.95 times 750, and we find that that's 712.5. So that is the number of values that would fall on that interval.